Welcome to the Podkey summary of Explore enhancements to visionOS object tracking from WWDC 2026. This update is really about making object tracking feel more usable in the real world. Faster tracking for handheld objects, more reliable training, true metric positioning, and a much more practical path for building spatial accessories all point in the same direction. It also opens the door to bringing the same object tracking workflows onto iPhone and iPad, which is a pretty meaningful shift if you're building across Apple platforms. One of the bigger improvements here is high frame rate object tracking. Apps can now get object position updates at the display's full refresh rate, which makes a real difference when the thing being tracked is moving quickly in somebody's hand. That matters because handheld objects don't move like furniture. They twitch, rotate, dip out of view, come back, and generally behave like objects people are actually touching. What's nice is that developers don't have to turn this on across the board. With the new Reference Object Configuration API, high-speed tracking is something you opt into per reference object, so you can save the heavier tracking behavior for the cases that actually need it. Apple is also extending training in Create ML with a longer, more data-intensive mode. The point is simple. Put in more training work up front, and you get much stronger tracking accuracy and robustness later, especially for objects held in the hand. That extended training mode shows up in the Create ML interface under the Object Tracking template, and it's also available from the command line. That CLI piece is quietly useful because it means remote training and automated pipelines are on the table. If a team wants to batch jobs or fold this into a larger workflow, they can. Another important addition is the Metric Space Pose API through ARKit coordinate space correction. Developers can ask for an object's pose in true metric coordinates without display correction offsets mixed in. In plain language, it gives you coordinates you can trust for measurement. If you're building something like a medical app that needs to measure the distance between points on a probe, being a little bit off isn't a cosmetic issue. That same idea carries into other uses too, like guided assembly, home remodeling, or training scenarios, where the whole experience depends on spatial dimensions being accurate in real time. Put the high frame rate tracking together with metric space poses, and the practical result is much better measurement on handheld objects. The example shown here was measuring distances between points on a probe against a spine model. That's a very specific demo, but it gets the point across. Once tracking stays stable during fast hand motion, and the coordinates are truly metric, a lot of precise spatial workflows start feeling possible instead of theoretical. There's also a platform expansion here. visionOS reference object files now carry over to iOS 27, so the same USDZ-based models can be used in ARKit world tracking sessions on iPhone and iPad. Developers can assign objects as detection, objects for stationary detection or tracking, objects for high frame rate behavior, then respond through ARObject anchor callbacks like did add, did update, and did remove. That reuse is a big deal because it reduces duplication. If you've already built object assets for one Apple spatial platform, you're not starting from zero on another. On the hardware side, Apple laid out the requirements for compatible spatial accessories pretty clearly. You need a visible LED constellation, an inertial measurement unit, and Bluetooth, so the accessory can communicate with Vision Pro. From there, developers can add extras like buttons or haptic actuators to make the accessory more interactive without breaking compatibility. So the baseline is strict enough for tracking, but not so rigid that every accessory has to feel identical. The placement guidance is practical and pretty important. LEDs should be spread out to create a pattern that's distinctive and visible from lots of angles, and the IMU and LEDs need to be rigidly mounted so motion doesn't introduce drift. For handheld hardware, the advice is to keep LEDs away from grip zones, which feels obvious right up until a human hand covers half your design. For larger accessories that sit farther away, the answer is more LEDs and more spacing, so the system can still track reliably at distance. Apple is also giving developers a dedicated accessory tracking debug view in developer mode. It shows LED brightness, how distinct the pattern looks, and whether synchronization is working through the headset's IR camera. It also reports IMU frequency, latency, and per-axis metrics, and it can verify timing sync using the headset's IR illuminators as a reference. That kind of tooling matters, because accessory problems are often physical, timing-related, or both. You really want a way to see what the headset is seeing instead of just guessing. For teams that don't want to build custom hardware on day one, third-party kits from DF Robot and Micro are coming later this year. The idea is simple. Ready-made boards you can mount onto an object and start testing with right away. That should make early prototyping much easier, especially when the goal is to test an interaction before committing to a full hardware design. There's also a new update, accessories method for swapping the active spatial accessory in the middle of a session, paired with GCS spatial accessory discovery. So, if a user moves from one tool to another, like a flashlight accessory to a steering wheel controller, the app can follow along without interrupting tracking. That's the kind of small-sounding API that usually makes the whole experience feel less brittle. Taken together, this feels like a very practical round of improvements. Better motion fidelity, better training, better measurement, and fewer barriers to testing real accessories is a solid combination. And honestly, any update that reduces the amount of hardware guesswork and mystery drift is doing good work. This episode was generated by Podkey. Create your own at podkey.fm.